Okay, so let's start with the session, and I'm going to share my screen. I hope people can see the screen. So, as you all know, this is the course name Nuclear Particle Physics, and today I will talk about assignment 7, week 7, previous year question papers. Okay, so let's start. In that whole class there will be nine, I think, yes, nine questions should be there, and we will discuss these 9 questions. So first of all, there is a first question. Use Gelman-Okubo mass formula. Can you hear me? Can anyone confirm? Am I audible?
Yes, ma'am.
Okay, fine. So the question is, use Gelman-Okubo mass formula to find the mass of lambda baryon, and what are given here? The masses of the nucleon is Mn, mass of xi is Nz equals to something, and the mass of sigma is also given, and give your answer into the closest integer in MV by c square. So this is the question. So I think all of you already know what is Gelman-Okubo mass formula and how it has calculated. How we can derive the mass formula. I think you all have known that. So if you know this, how the derivation is coming, then we can just directly write the formula of the Gelman-Okubo. Okay. Or otherwise, if you don't know, then you can tell me. I will derive that one also if you want. Okay. But yeah. So I think you all know that how to derive that Gelman-Okubo mass formula for that quark masses and all. That in terms of quark masses, how can we know the particle mass? So if I write here the formula a little bit, then it will be like, let's say I am writing here I and Y. M is the mass of that particle in terms of I and Y. I is the isospin and Y is the hypercharge. So what will be the value for this? This will be like K0. I am just taking the same notation what Sir is using in his class, so that it will be very simple to understand all of you. So this is K0 plus K1 into Y plus K2 into I plus 1 minus Y square by 4. So this is the expression. So this is the expression for mass of any particle which has the I value, which has the isospin as I and hypercharge as 1. So if I write this formula and if I just put these values, like you can see that Mn, M xi and M sigma. So Sir has already derived one expression for these 3, and we are just going to write this one. But if you want, then I can also derive that formula also. But let me first write that one, and after that I will reproduce the answer, and after that, if you have any problem on the derivation of this expression or something, then I will derive that one also. Okay. So the expression is like, and I am also going to write here. Yes, the expression is Mn plus M xi divided by 2 is equals to 3 into M lambda plus M sigma divided by 4. This is the expression. Okay. So if you know the expression, then obviously in that equation, in that question, what they are asking? Okay. In that question, they are asking about the mass of lambda. That means they are asking about M lambda. What will be the M lambda value? Okay, so what will be the value of M lambda? And in that question, what they have mentioned Mn, they have also mentioned M xi, and they have also given M sigma. So by putting Mn, M xi and M sigma value in that expression, then we can get the expression for M lambda. Okay, that is very simple. So let's try that one. Okay, so first of all, I am just going to write all the masses, whatever it is given here. Mn sigma. Okay, so what is Mn here? Mn is 940 1329. Okay, 940, 1329. I am writing here MEV divided by c square for each and every one because the mass is given in MEV by c square unit only. And what it m xi m sigma है 1190 MEV by c square. Okay, so these three are given in that question. So now what we will do, we will just write the expression again, that mn plus m xi divided by 2 equals to m lambda plus m sigma divided by 4. Fine. Then you can see that from that expression we can immediately write m xi equals to 3 m lambda plus m xi, and 2 is there because you can see that this 2 and 2 will cancel out and there will be 2 and these 2 will be multiplied here whole, so that we can have 3 m lambda plus m sigma equals to 2 into mn plus mxi. Then what will be the m lambda? M lambda will be 2 into mn plus mxi minus m sigma whole divided by 3. Sorry, this whole divided. So this will be whole divided by 3. Okay, now calculate with the calculator what will be the value of this one. Okay. Yeah, so mn is 940 plus m xi is what? 1329. 1329. Fine. This one into 2 minus m sigma. M sigma is 1190 divided by 3. So 1116. Right. So I am just writing here 1116 MEV by c square. This will be the answer. Now I have given you can see here, yes, this one. Can you see that this is a table, right? In the table I have mentioned some of the particles, whatever it is in baryon, decaplet or baryon octet. Okay, you can see here I have just mentioned here particle name, particle symbol, then their isospins, their corresponding spin and their mass. And obviously the mass is in MEV by c square unit. Then whatever we got right now in lambda, let us check with this answer. How much we got? We got 1116 MEV by c square. As you can see from that calculator also, it is 1116. So now let's come to that table. In the table you can see that this is lambda, this is isospin 0 and spin is half, and also mass is 1116 MEV by c square. Right? That means whatever we have calculated, that is exactly correct. Okay, so how I just mentioned that one, I just mentioned that one from a book, so that we can just tally that whatever we are getting, that is correct or not. Okay, so this question has already done. So with the help of Gelman-Okubo mass formula, we can find the value of m lambda with the help of, it is as a function of mn, m xi and m sigma. So with the knowledge of these three mass, we can have the expression for m lambda, and from that expression we can get the value of m lambda. Okay, and we have already cross-checked that one. Whatever we are getting, that m lambda value is exactly same whatever it is in the table, 1116 MEV by c square. Okay, so is there any problem on that first question? I think no, right? Okay, so if there is no question in that first question, then we will go to the second question. See, here in that second question, I will tell you one thing, that I did not notice that it is already in the this year's question paper, that assignment paper. So should I answer the question? I don't think that it should be correct that I will answer the question right now here. But still, like, it was also in the last year question paper also, so that's why I just mentioned here. But okay, like, for the knowledge purpose I am just going to tell you. Okay, I don't take it as a don't take it and don't copy in your answer sheet that it is the assignment answer. Okay, so in the electron nucleus scattering, the cross section written as d sigma d omega equals to d sigma d omega Rutherford into f function of q square, where d sigma d omega Rutherford is the Rutherford scattering cross section, and they are asking that what is f q square. So there are four options. One is it is a correction function to indicate that nucleus is not a point particle. It is a correction factor to include the effect of nuclear spin. It is a correction factor showing the relativistic effects to the scattered electron. And the fourth option is it is a correction factor to include the spin-spin interaction of the electron and the nucleus. So whatever said gave in his lecture, at that time only he already told about fq square. So if q square is what? If q square has a name, it can also be written as form factor. Okay, so form factor means what? I mean, this is a function of q square. As you from that notation you can see that f is a function of q square. Okay, and the q square is what? This is the transfer momentum, right? So it is a correction factor known as form factor, and this correction factor indicates that the nucleus is not a point particle, because inside that nucleus there is quarks, right? I mean, obviously there is proton as well as neutron, and inside of neutron and proton itself there is some QUDD or UUD, something like that. So that means there is a quark nature is there inside of this nucleus. So as this quark nature and as well as the nuclear structure, we don't know the exact nature of these things. So that's why, and also the momentum transfer between these two or from here to here, the momentum transfer is nothing but q square. So whatever is f q square, that indicates that our inside that nucleus proton and neutron is there, and proton and neutron itself are making of and itself a function of quarks. That means UDD or UUD, something like that. So obviously whatever it is the form factor fq square, that indicates the nature of the nucleus, that nucleus is not a point particle. So the correct answer will be So the correct answer will be A. Just a minute. So the correct answer will be A, that form factor is a correction factor which indicates that nucleus is not a point particle. And none of the above will be the correct one. Okay, so the correct answer will be A. Fine, this is a very simple question. Now we will talk to the third question. In the third question you can see Mott scattering formula for electronuclear scattering is written in terms of Rutherford scattering formula as d sigma d omega equals to d sigma d omega Rutherford into 1 minus v square by c square sin theta by 2, where v is the speed of electron and c is the speed of light in vacuum. The correction factor 1 minus v square by c square sin theta by 2 takes care okay, so there is like 1 minus v square by c square sin theta by 2 is there in that expression of d sigma d omega. So they are asking that 1 minus v square by c square sin theta by 2, this term is what? I mean, what is the meaning of this term and what takes care of this term? Is it the spin-spin interaction of the electron and nucleus? Is it the relativistic effect? Is it the factor that the nucleus is not a point particle? Or is it the spread of the electron beam? So obviously you can remember that there is 1 minus v square by c square. This term is very similar. Like let's say our theta is 0 degree, then 90 degree, and then theta by 2. Yes. So if theta by 2 is 90 degree, then you can see that 1 minus v square by c square sin theta by 2 is reduced to 1 minus v square by c square, right? So this term is what? This term is nothing but as a correction terms which include due to the relativistic nature of electron. Okay, so you can see here the spin-spin interaction will not be the correct one, the relativistic effect will be the correct one, and obviously C and D will not be the correct one. So here the correct answer will be B, because there is the term 1 minus v square by c square sin theta by 2, and 1 minus v square by c square is nothing but coming from the relativistic effect correction of electron as a relativistic particle. Okay, so I have seen right now that these two questions are already in your this year question paper, so just ignore these things right now because you have to write by yours own. Okay, now coming to the fourth question. So this is the fourth question. Resonance scattering processes like EP going to E delta star is also going to EP pi indicates that proton is a point particle, proton has electric charge, there is structure within the proton, and proton is relativistic. So to know the answer of that question, what we will write here, I am just going to write the expression again. EP going to E delta star going to EP pi. Okay. So this is the expression, right? So in that expression you can see that our EP, I am just going to write it like that so that it will be understandable clearly. E plus P plus pi. So let's focus about this one at first. You can see here E plus P going to E plus delta star. This type of expression can be possible only which condition? Okay, you can see here the first one was electron, the outgoing particle is also electron, but the main problem is here it is proton and here it is delta plus. So how it can be possible? There can be two things. One thing is that whatever the P is there, this proton is taking the energy from electron, and this energy with the proton can go to an excited state, and then that excited state can produce delta star. That is also possible. And also with that, with the taking the energy of electron also, there may be another possibility, and that possibility is like that. Let's say it is taking the angular momentum of electron from it is taking the angular momentum from electron, and the proton, inside the proton there may be some energy state difference or some excitation of the energy states, so that it will become delta star. You got my point? Basically what happened here, the proton is UUD, and whatever the D star will be there, it is also UUD quark content. But the main difference between P and delta star is that the energy of P is very lower than delta star, and the energy can be found by which condition? Let's say our U and D is like that. Let's say U and D are in ground state in P, but in delta star it is like excited state. So the main difference is that our EU can go to the excited state, this U can also go to the excited state or something like that. So if our P has nothing, let's say our P is a point particle, there is nothing inside of this like UD or UDD something. So if there is nothing inside the P, then we can't get from P to delta star. Okay, because there will be no inside particle. If there is nothing as an inside particle, then it can't go to that higher excited state, or it can't change its spin also, because you can see that for proton the spin is half, but for delta plus it is the 3/2. So that means spin is also going to change. So how can it possible? This is possible because of our P is not a point particle. If it was a point particle, then P can't go to delta star in this expression, because all other particles are exactly same. The electron is same as electron. Only the difference is P is going to delta plus delta star, and how it can go? It can go because of the presence of quark inside proton. Okay, so whatever the question are asking, like resonance scattering process, EP going to E delta star going to EP pi, indicates that proton is a point particle. It should not be correct. Proton has electric charge, that is fine, but from this expression we can't conclude that proton has electric charge or not. But from this process we can definitely conclude that there is structure within the proton. And obviously from this point of view we can't say that proton is a relativistic particle or not. Okay, so the correct answer will be C, that inside the proton there is something. Okay, so inside the proton there is some structure. So only in this condition EP can go to E delta star, and again the delta star. Okay. And after, as a delta star is a resonant particle and it is unstable in nature, then this delta star can go to P and pi in the next decay mode. So I think it is clear to all of you that how EP is going to E delta star can have a conclusion that proton itself has a structure within it structure. And what will be the structure? Obviously we all know that P is U, U, T. That means there are 3 quarks inside the proton. Okay, I think it's already understandable. Now coming to 5. Okay, so in that question number 5 you can see, take the quark content of pi 0 as U bar. If you know that pi 0 has a quark content U bar plus D bar plus S bar 1 by 6, like that. But right now we are not going to do that. They have already told us that pi 0 has a quark content U bar only. Just take that one. Good. Its possible isospin value is what? They are asking that what will be the possible isospin value for this combination U bar. Now I think from that lecture, like Professor Paulus Paulus lecture, you got the knowledge that particle, not exactly particle, it should be quark. Quark, U, T, spin, isospin, and I3 value. So I think you have already known these things because it's already given in his lecture. So I'm just going to write it again. So for quark, U and D, the isospin will be half for each and every. For U also and for D also. But for I3 value it is plus half and it is minus half. For U it is plus half and for D it is minus half. Okay. And now we are coming to the expression that U bar. So you can see that there are 2 U's. One is in particle and another one is antiparticle form. Right? So if I am just going to calculate the I value for this combination U bar, then what will be the answer? See, here for I value, this U has half I. This U bar is also have a half I. So the combined I should be, let's say, U bar. This has one I1, this has I2. So I1 is half I2 is half. So what will be the combined value of I? As it is a vector summation, we can write like that: mod of I1 minus I2 to mod of I1 plus I2 in steps of 1, right? So this is the answer for that. Now coming to the values here, I1 is half, I2 is also half. Then what will be the value of I? I can have the value half minus half to half plus half in steps of 1. Good. Then what will be the value for I? You can see that I at the very first, I half minus half means what? 0, and half plus half is 1. So 0 or 1, and in steps of 1 means there will be no other terms in between 0 and 1 for I value. So we can conclude that the isospin for the combination U bar can have the value 0 or 1. Now coming to the question again. Yes. So take the quad container 5 U bar. Its possible isospin value is what? And there are 4 options: 0, half, 1, 3 by 2. So the possible answer will be A as well as C, because we have seen that the I value can have 2 values, 0 and 1. So the correct answer will be A as well as C. Okay. Okay, so I have already told you about 5 questions. So till now, is there any problem? You can ask me right now, or we will just continue for the next questions also. So that, and after that, at the very last also, you can ask all the questions again. Okay, now coming to the 6th question. In that 6th question, you can see which of the following could not possibly form an isospin triplet. See, here it is already written here in bold. Okay. Oh, thank you. Okay, so which of the following could not possibly form an isospin triplet? See, actually these questions are very simple, so that's why I think all of you already got these answers. But still, as it is the duty of ours, so that's why we have to take these days. Yeah. So which of the following could not possibly form an isospin triplet? So you can see here it is written that could not. That means which one cannot be the isospin triplet. So what is basically isospin triplet? You can see, you can remember, if I am going to write here baryon octet, then you can see like here, here. It can be baryon octet as well as it can be meson octet also, right? So it is like baryon or meson octet. So in that baryon or meson octet, you can see here that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. So here this one, and this one. These 3 are making an isospin triplet, right? Similarly, you can see for the baryon decaplet. For that also, what is the structure? The structure is like this. So here you can see 1, 2, 3, 4, 1, 2, 3, 1, 2 and 1. So here as a whole, this is a isospin quadruplet. It is not triplet because there are 4 members in this row. Similarly, this is isospin triplet because there are 3 members in that row. This is isospin doublet, this is isospin singlet, right? Now you can understand what is the meaning of isospin triplet. Isospin triplet means in that family there will be 3 members max to max, right? So that we can say that okay, this is isospin triplet. Now coming to the question again. So in that question there are 4 options given. Let's, I'm writing here U, okay. U, D, and D maybe. Yes. Then U is, UUC, UUB, UUC, UUB. Then again UUS, okay, UUS, UDS or what? UDS, I think. Yes, UDS and DDS. What is that? Yes, DDS. And the fourth one is UUC, UUC, UDC and DDC. So there are 4 options, right? So coming to the first option at first. Can you remember what is the quark content of UUU? I mean, which one is this? U is nothing but delta plus plus, which is placed here. So as per I already told, this is the decaplet, and in the decaplet you can see that delta plus plus, delta plus, del 0 and delta minus is there. So that means as a whole 4 members are there in that row. So this cannot form a isospin triplet because it is already a isospin decaplet, a quadruplet. Okay, quadruplet, because 4 members are there in this family. And from quark content, how can I say this? Obviously we can say, because UUU, UDD, sorry, just a minute. UUU, UUD, UDD, and also there should be one thing, DDD, right? So you can see that from this quark content level we can have the idea that it will be isospin quadruplet, not triplet. But how can I write these things? Okay, I am telling you one trick so that you can understand simply. Whenever you will go from, let's say, right to left, then one D will be replaced by one U will be replaced by D, and when you are going from top to bottom, one U can be replaced by S. Okay, I mean in that baryon decaplet, if you see carefully, then it will always happen. So that we can simply say, by knowing only one particle quark content, we can tell all other quark particles. How? Because you can see here, as I know this is UUU. So what will be this one? This will be UUD, because one particle will be replaced by D. So what will be this one? This is UDD, because UUD was previously, and here I told that U will be replaced by D. So that means UDD. What will be this one? This one will be DDD. Fine. Now coming this point. So what will be the quark content of this point? This point will be, I told you that one U will be replaced by S. That means UUS. Now coming to this one. What will be this one? As I told, from here to here, when we are going from right to left, then one U will be replaced by D. That means it will be UDS. What will be this one? This will be DDS, because this U can be converted in D. Now coming to from here to here again. What will be this one? This will be USS. Now what will be this one? This one will be DSS. Now coming to this one. Now you can see from here, USS was there, but one U can be replaced by S. That means SSS. This will be quark content for this part. Right? So for after knowing only one particular quark content, we can already make all other quark contents. Okay. So now coming to the this question again. So from this first option, we can see that this is not making an isospin triplet, because it itself an isospin quadruplet. Now coming to the third option, second option. In that second option, you can see UUS is there, UUC is there, UUB is there. But in that, from that point of view, we can see that whenever the isospin triplet will be there, in this isospin triplet condition, one U can be replaced by D. All other things will be same. Okay, so this cannot be a isospin triplet. Now coming to this one, you can see here, let us calculate at first UUS. So at first UAs was there, and I told you that for isospin triplet one U should be replaced by D. Then what will be the next particle for this triplet, or whatever, if it is a triplet? It will be UDS, because one U is converted to D. And what will be the next one? The next one will be DDS. Now you can see that UUS, UTS and DTS, these all are here present. That means this one can be a isospin triplet. Now coming to this option, UUC. So I told you that in isospin triplet U can be replaced by D. So what will be this one? UDC. Again what will be this? DDC. So if it is like that, UUC, UDC and DDC, that type of thing can make a isospin triplet, is it? UUC, UDC, DDC. Then the correct answer is also this one. So if I go back to the answer, the question is like, which of the following could not possibly form an isospin triplet? Could not. That means we have to calculate which one is not possible. So we have already told you that the B is not possible, as well as the A is giving isospin quadruplet. It is not isospin triplet. That means A and B will be the correct answer for this question. So how can we understand that it is isospin triplet or not? Obviously we have to see that our U is replaced by D or not. This is the simplest way. Okay. Now coming to the next question. This is question number 7. Select the correct statements bringing the solutions K minus and K0. Okay, K minus and K0. And there are 4 options about these things. And we have to calculate which one is the correct one, or how many are the correct one and who are they. There may be possible that more than one is correct one. Okay. So now coming to K minus and K0. First of all, I just want to draw a picture. This is this one octet. Why I am just going to draw this picture? Because K minus and K0, these are nothing but the particles of this one octet. Now I am writing this one. So this is pi minus, pi 0, pi plus. Here is also eta 0. This is K plus, K0, K minus, K0 bar. Okay, this is the Meson octet picture. Now from this picture, okay, yes, in that x-axis it is I3, in that y-axis it can be S or it can be Y also. That is no problem, whatever we just want to do. So yeah, so I3, I told you that these 3 can make a isospin triplet, right? So if it is a isospin triplet, then what will be the value for I of isospin triplet? That will be 1. I mean for pi. Okay. So if for pi I will be 1, then how many I3 value will be there? There will be 3 I3 value. Minus 1, 0 and plus 1. So for pi minus, the associated I3 will be minus 1. For pi 0, the associated I3 will be 0. For pi plus, it will be 1. Good. Now you can see that from 0 to 1 there is another point. So obviously what it will be? It will be half. And this point is also minus half. Right? Now you can see that this point is nothing but corresponding to this point also. And this point is corresponding to this point. Actually I am not going to draw that one properly, but still. So K plus has I3 plus half, K0 has I3 minus half. I am just writing that one. K0 has I3 minus half, K plus has I3 plus half. Similarly, K minus has minus half, and k0 bar has plus half. These are the value of I3. Okay, so if it is I3, okay, so how many options are there? They both have opposite strangeness, they both have the same hypercharge, they have the same isospin but differs in the third component by 1 unit, they have the same spin. Okay, so we are going to the last one. So they have the same spin. Is it correct or not? Yes, it is correct, because all the particles, whatever it is in that meson octet, all the particles have spin half. So you can see that. I am just going to write it again because it's already messy. So this is pi minus pi 0, pi plus k plus k0, k minus k0 bar. So in that meson octet, you can see that all the particles are having spin half, and we are talking about two particles, which are these k minus and k0. So we are talking about this one and this one. So as these two are present already in that meson octet, then obviously the spin of each particle will be half. So whatever they have told as they have the same spin, that will be the correct one. Okay. Now coming to the third one. They have the same isospin but differs in the third component by 1 unit. That means they told that our k minus and k0 are getting same isospin, but they are differs by the I3 value. So is it correct or not? We have to check. So see here. So as I already mentioned here, this is 0, this is I3 value, right? This is half, this is 1, this is minus half, this is minus 1, right? So from that figure you can see k0 and k minus have the same I3, right? So they have the same I3. So whatever they are talking about, that they have the same isospin that differs in the third component by 1 unit, that will not be correct one, because from that figure we can simply say that the I3 of k0 is minus half, as well as I3 of k minus is minus half. So these two particle has the same isospin. Okay, I mean third component of isospin. So whatever they are telling, it is correct. It is not correct, it is not. Now coming to the second one, they both have the same hypercharge. Is it? We have to check. So both have the correct k0 and k minus, right? So k0 and k minus. So what will be the hypercharge for these two? Okay. So I have already calculated that k3 of k0 is minus half, I3 of k minus is also minus half. Now you can see the q of k0 is 0, q of k minus is minus 1, right? So from the Gelman-Nisijima formula I can have the expression this one, right? So first of all I am talking about k0. So k0 has q0, I3 is minus half plus y by 2. Now what will be the value of y for here? You can see that y will be 1 for k0. Now coming to k minus. Q equals to I3 plus y by 2. For k minus, I3 is minus half. And q of k minus is minus 1, right? So I am just going to write here minus 1 minus half plus y by 2. So what will be the y by 2 value? Minus 1 plus y by 2 is minus half. Then you can see that y value is minus 1. And previously for k0, y value was plus 1. So for k0, y value is 1, for k minus y0 y is minus 1. That means hypercharge is not same. So they both have the same hypercharge. This is not correct. Okay. Now coming to the first option, they both have opposite strangeness. One is positive and the other is negative. So we have to calculate is it correct or not. Okay. So you can see from this expression also that y is b plus s, right? We all know that, right? Now for k0, y is 1, right? Y is 1, yes. So for k0, what will be the b value? Obviously k0 is not a baryonic particle, that means b value will be 0. So from that equation, y equals to b plus s, the s value of k0 will be only y, which is 1, right? So the strangeness of k0 is 1. Now coming to the k minus case. So you know that I have already written k minus, for k minus y is minus 1. So if I write here this one, then s will be only y because b is 0 here. So s will be minus 1 for k minus, right? Then you can make a summary that s of k0 is plus 1 and s of k minus is minus 1. So that means what? That means our strangeness of k0 and k minus are differed by sign only. They both have opposite strangeness, one is plus and one is minus. So that means A will be the correct one. Okay. So how many statements are correct here? A will be the correct one. So the answer will be A will be correct one, D will be correct one. B and C are not correct. Okay. I think it's understandable. Okay. So then we are going to the next question. Or if you have any problem, you can just tell me right now, because you know that that will be a very simple thing like elementary particle physics course. Okay, so if you don't have any question, then we will talk about next question. In that question, one of the d missions is made of a U antiquark and a C quark. Oh, there are two and one of the d missions is made of a U antiquark and C quark. What is the electric charge, hypercharge, and the I3 value of this mission? Okay. So, what is the question? In that question, we are making that the quark content of D is U bar and C, right? U bar and C. This is the quark content of D meson. So, what they are asking? They are asking about Q value, Y value, and I3 value. Yes, I3 value. Okay, good. Then how can I calculate these things? So Q value first of all. So you all know about that Q value of all the quarks, right? U, D, C, T, B and S. So Q value will be what? 2 by 3 minus 1 by 2, 1 by 3, 2 by 3, 2 by 3 minus 1 by 3 minus 1 by 3. And what about I and I3? I will be half 0, 0, 0, 0. I3 will be half minus half 0, 0, 0, 0. Okay. Now at the very first we have to calculate Q bar charge. What is the Q bar charge? If Q charge is 2 by 3, then Q bar charge will be minus 2 by 3. Now C is what? 2 by 3. plus 2 by 3. Then what will be the answer for that? 0. So what is the D meson? For that D meson, the Q value will be 0. So first of all, we get the value of Q here. Now coming to the I3 value. So I have already written here U, D, C. I don't care about all other things because you know that our D is U by C. So Q is 2 by 3 minus 1 by 3, 2 by 3. Now this is half, 0, half minus half, 0. So for U bar, what will be the value of I3? I3 will be minus half for U bar. Now what will be the value of I3 for C? It will be 0, right? Now we are just going to calculate whole I3, that means I3 of D. What will be this one? This will be minus half plus 0, which is minus half. Okay, so what is the value of I3 of D? It will be minus half. Okay, now coming to Y value. We have already knew that Q equals to I3 plus Y by 2. And from that previous calculation, we got the knowledge that Q of D is, I have already written here, Q of D is 0. So I am going to write here Q of D is 0. And again I got the knowledge that Q of I3 is minus half. These two I got from these previous calculations. Now what will be the Y value? Just we have to put this minus half plus Y by 2. So Y by 2 will be half and Y will be 1. So from all of these I can get 0, I3 of D minus half, Y of D, this 1. I think 1, right? Yes. So these three are the correct answer. Now coming to the answer. 0 minus half 1. So there are two questions 0, 0, right? Minus half is I3, that means this one, and Y is 1, that means the correct answer is D. Okay, I think it's already understandable. Okay, now coming to the last question of today's session. Here's the items in the following two lists. What is the list here? You can see here that in 1, 2, 3, 4 there are 4 things, and in ABCD there are 4 things. So we have to match, let's say 1 to ABCD, any one of ABCD, 2 any one of ABCD, something like that. Okay, now in the left hand side what are they? Proton, lambda 0, antineutron, K plus. And what is in the right hand side? Right hand side is strangeness equals to 1, UUD, baryon, spin minus 1. Okay, so proton. Proton is what? You all know these things. Proton is a baryonic particle, and the quark content of proton is what? UUD. Right? So immediately I can tell 1 can go to B. Very good. Now coming to lambda 0. Lambda 0 is what? Lambda 0 is a baryon. Right? Then 2 will go to C. Now coming to antineutron. Antineutron. Okay. So neutron has spin what? Neutron has spin half. Right? So antineutron. Antineutron means this is the antiparticle of neutron. So antineutron spin is minus half. So you can see that from this expression, this is the D. That means 3 will be D. Now coming to K plus. K plus is obviously only one option is left here, that strangeness equals to 1. But we have to check is it correct or not. K plus has the strangeness plus 1 or not. You can remember that from this Mason octet we can have the knowledge that K0, K plus, K minus, K0 bar, pi minus, pi 0, eta 0, pi plus, right? And here I3, here S or Y. So we have already calculated that this point is 0, this one is plus 1, this one is minus 1, this one is minus 1, this is sorry, this point is 0, this is half, and this is 1, right? So from that equation we can obviously tell that the strangeness of K plus is what? The strangeness of K plus is 1, because it is in the topmost row. So from that we can tell K plus is 1. I mean K plus has strangeness 1. So that means 4 has A condition. So which one will, what is the right condition? The right combination of these two is like proton is this one, lambda is this one, antineutron this, K is this one. So 1A, 2B, 3C, no, 1B, 2C, okay, and 3D, 2A, 4A, sorry, 4A, 4A. So this is the combination, right combination. So up to this, there were 9 questions of previous year question paper. So if you have any doubt, you can ask me, or otherwise I have to tell you something more, but still, yeah, you have to ask me right now. Hello, can you hear me?
Yes, ma'am.
Yes, you are audible.
I was disconnected.
Yes, ma'am.
Oh my God, I did not understand that I was disconnected. Up to which I was disconnected? I mean, I did not understand that I was disconnected at which time. So, can you see that last question or not?
Ma'am, you were just starting question number 9.
With just starting of question number 9, I was disconnected, right?
Yes, ma'am.
Oh, sorry. Okay. Then we have to tell these things again, I think. Just a minute, yeah. I think I was not disconnected and you people were hearing me. Okay, fine. Just a minute. Oh, otherwise I can start from here also. Yeah, so in that question you can see, match the items in the following two lists: proton, lambda 0, antineutron, K plus, and in the right hand side it is strangeness equals to 1, UUD, baryon, and spin minus half. So we have to match these things. So first of all, in any elementary particle physics course, whenever you are going to whenever you are going to attend the course, obviously there will be proton quark content. What is the proton quark content? Proton quark content will be UUD. So from that you can simply say that A is 1 is connected to B. Okay. Now coming to lambda 0. Lambda 0 is what? Lambda 0 is a baryon, right? So then we can write lambda 0 baryon. That means 1 is connected to B, 2 is connected to C. Now coming to antineutron. Basically, neutron has spin half, right? And antineutron. Antineutron is what? Antineutron is nothing but the antiparticle of neutron. It has spin minus half. Okay. So whatever it is given in the question, the antineutron, it will be spin minus half. Now coming to K plus. Obviously in that list you can see that only A is left. So obviously we can tell that K plus has a strangeness minus 1. But how can I tell these things? If we don't know about any of these, then there will be some more possibilities there, right? So K plus has strangeness 1 or not, we have to check that. So for this, what we will do? We will just write there this is Mason octet. Okay. So this is Mason octet. In that Mason octet, you can see that this is I3 and this is S or Y, because in Mason B is 0, so that means X and Y has the same value. Now here K0, K plus, K minus, K0 bar, pi minus, pi 0, pi plus, and here also eta 0. Now you can see that for K plus and then in that y-axis pi 0, pi plus, pi minus, these are not a strange particle. So that means the value of this point is 0. Now coming to here, this will be obviously 1 and from here it is z minus 1. So from that notation I can say that this is K plus, right? So I mean the K plus has the value of strangeness as plus 1. So the strangeness of K plus is 1. Now coming to the question again, you can see the K plus has a strangeness 1. That means this one will be corrected as this one. So if I write correctly, then the connection will be like 1 to B, 2C, 3D, 4A. This is the correct combination. Okay. So now if you have any question about these 9 questions, you can ask me or we will do something else.
Ma'am,
Yes.
can you please show question 5 again?
Sorry?
Can you please show question 5 again?
5.
Yes, ma'am.
Okay. Sure. 5. Then it's 5. This one. Yes.
Yes, ma'am.
Okay, so should I tell you again this one?
Yes, ma'am. I missed this question.
Okay, fine, no problem. So here take the quark content of pi 0 as u bar. Okay, its possible isospin value is what? So let me clear these things first. I have already written the answer here, so let me clear that one at first. So for quark content of pi 0 has a quark content u bar. They are asking that what will be the possible isospin value. I mean that means they are asking about I value, right? I is the isospin. So if you remember here that, I think I have already mentioned here, yes. If you remember about Q, U and D, the quark content of U is, isospin is half, I3 is half. For quark content of D, isospin is half, I3 is minus half. So from this figure we can simply say that the isospin of U is half. Again, the isospin of U bar is also half, right? So this is nothing but a 2-component state. So one is U, another one is U bar. That means our pi 0 is the linear combination of U and U bar. So what will have? The I1 is half, I2 is also half. Now what we will do? We have to calculate I value. So just very simply we are just going to calculate that one with the help of quantum mechanics vector summation. So for the vector summation, what we will do, the I value can have mod of I1 minus I2 value to mod of I1 plus I2 value in steps of 1, right? So here you can see that I1 is half, I2 is also half, then I1 minus I2 is what? It is 0. So 0 to I1 plus I2, I1 plus I2 is what? 1. 0 to 1 in steps of 1. So if 0 to 1 in steps of 1 means what? Only 0 and 1 value will be possible. There will be no other value in between of 0 and 1. So the correct answer of the isospin I of U bar combination will be 0 and 1. So the correct answer will be 0 as well as 1, because they are asking that its possible isospin value. So it may be 0 or it may be 1. Okay.
Yes, ma'am. Thank you.
Okay. But let's say I am asking about I3 value. I mean, what will be the I3 for pi 0? As I3 is an additive quantum number, then we can simply say this is I31, let's say this is I31 for U is half, and I32 for U bar is minus half. Then what will be I3 value? I3 value will be half minus half, which will be 0. So I3 value will be 0, but I can have two values, 0 as well as 1. Okay, someone is there. Oh, okay. So yeah, so we have already discussed all the questions for today, but still I am just going thoroughly, so that if you have any questions you can ask me right now. This is question number 1. This is question number 1. Then question number 2 is this one. Sorry. This is question number 2. Now question number 3 is this one. Now question number 4 is this one. Now question number 5 is this. Question number 6 is this. Question number 7 this. Question number 8 is this one. Question number 9 is this one. So there are 9 questions. Okay, so I think all the questions are understandable by all of you. So I'm just going to show you this one. This one I think I have already shown you previously also, that particle. Okay, so this is particle content I, J, P, charge H, all these things are there. I have already mentioned this one in a previous week also. I mean, if you are just making these all the particles and their J, P and string trace number and all these things in a table form, then it will be very much useful for you people also. And this is the quark content of all the particles. I mean, not all the particles, but most useful particles. These are the quark content, and this is the little bit mass of these particles. Like this is the for meson, and whatever I have mentioned in the first table, that was for barium. I think you have already remembered this one, that where is this one? Yes, this one. Where is it? Yes, this one. What? This one is for baryon particles, and baryon particle corresponding masses are there. So these are the things. Now if you have any question, you can ask me, or we will meet in the next class. And next class will be on 8th assignment. Yeah, 8th assignment number 8. Yeah. So is there any question? Okay, so there is something in chat box. Yes ma'am. Okay. So do you have any other question? You can ask me. I think in that assignment, whatever I am talking right now, most of the questions are very similar to this year assignment also. So maybe it will be helpful for you. Obviously there should be different questions also, but yeah, very similar to this one also is there. So if you have any other questions, other comments, other doubts, anything, you can ask me. Or if there is nothing, then we can stop today's session and we will meet next class. Yeah, something is there in the chat box. Thank you. Okay. Okay, then I think we should stop to discuss. Is there still anything to share or anything? Our session. Okay. And we will see you